Okay, let's give you guys some more practice. So the equation for this red line here, is given by this. If you look at this arc here corresponds to this arc here. So if you rotate this arc 360 along the y-axis, it would give you something like this. Okay, it would give you something like this, and then it would give you this. So work out the surface area of this. Okay, so work out the surface area of this. So and remember, it's from 0 to the natural log of 2 here. Okay, natural log of 2. So it's from 0 to the natural log of 2. Okay, so press pause and have a go. Work out the surface area. Okay, so to do this, in your mind, try to visualize it like this. It's really you summing up all the strips. So if you rotate it, so if you look at this one particular strip, let's say this one here, the thickness associated with this would be dy. So it's going to be you summing up. It's going to be something dy here. Okay, and then you're summing up everything from 0 to this height here. So from 0 to this height. Well, this height here is the natural log of 2. And then if you look at this one particular strip here, this is your radius. So you need to get 2 pi. You need to find the circumference from the radius. Well, you're working in the x direction. Luckily, this was given to you in the form of x equals something, not y equals something. Well, you need to work in terms of the x direction. So it's going to be well, you need the circumference. So the circumference will be 2 pi r, but r happens to be this. So it's going to be this, y minus e minus y over 2. And then you need to times it with the arc length. Okay, well, the arc length is given by this. So this here is your arc length. This here is your circumference. Okay, so it's 2 pi r, but r happens to be this thing here. Well, the surface area will be given by this. Remember, from 0 to natural log of 2. So now it's just a matter of evaluating this. So our normal routine would be to start with this. So we need to find dx by dy. Remember, the equation is in the form of x equals something something. We need to work out dx by dy, not dy by dx. Okay, we need this. So work out the dx by dy, and then our normal routine would be to then square it, and then to add 1, and then hopefully this will cancel out with something in here. Okay, well that's our normal routine. Let's try and evaluate this now. So start with our x equals this. So start with this. So x equals this, but rewrite this as this. Hang on. So start with x equals that thing. So start with x equals that thing here, but rewrite it in this form here. So now it's nice and easy to find the dx by dy. So differentiate this with respect to y. That will then give you this. Okay, and then so we've got the dx by dy. So we've got dx by dy. Now we need to square it, and then later on add 1. Okay, so now we've got dx by dy. We need to square it. That will then give you this. Now multiply this out. So multiply this out, and then it will give you this. And then this times this. Combine the two, it will be 1. Combine the two here, it is e to the power 0, which is 1. Okay. So that will then take you to this. Okay. So now so now it's just well, if this is 1 here, then it's going to be a quarter, blah blah blah. From here, it will take you to here. Okay, and then just tidy up. So from here, tidy up. So we now need to add 1. Okay, so add 1 to both sides. That will then, so this is us adding 1 on this side. So that will then give you this. So now we've got what we wanted here. So now, So we've got this bit. We've got this now. So we need to put this into this square root, and then hopefully somehow try and get this to cancel out with what's in here. But the thing is, normally, so when you put this into here, e2y plus 2 plus e minus 2y over 4. Normally somehow you've got to try and get this to cancel out with this. So normally we would do this, square root 4, square root this, okay, and then somehow try and get them to cancel out. But in this example here, well, you've got to stare at this and play around. But in this case, in this example here, it doesn't cancel out. So, but what you should notice is that you can rewrite this in the form of something squared. Okay, this thing here you can rewrite it as in the form of something squared. Well, so normally this thing would cancel out with something in here, but in this example it doesn't. So you have to realize that this thing you can rewrite it as something squared. Well, this thing here can be written as this thing squared. Okay, because if you look at this here is e to the power of y plus e to the power of minus y over 2. If you square this, it will give you this thing here. Okay, well anyway, you can rewrite this in the form of something squared, in the form of this squared. So now the square root will kill off this square here. That will then give you this. Okay, that will then give you this. So now it's just a matter of evaluating it. This thing here is a constant. Take it out, and then multiply these two together. That will then give you this. Notice that it's a quarter there. You can actually take the quarter out here. Okay, so that will then give you this, and then integrate it. It will then take you to here. Integrate it. It will then take you to here. So now you've got to put this into here. That will then take you to here, and well, from here it will then take you to here. Okay, but this bit here is quite tricky. This bit here is quite tricky. What does it mean to have 2 times something? So so visualize this thing here as it's just like you having this x a b, but then visualize it as x to the power of b to the power of a, or you can visualize it as a to the b, whatever. Well, visualize this thing here as this. Okay, so these two really cancels out, giving you a 2. So it's going to be 2 squared. Okay, which will be 4, and blah blah blah. And then this thing here, visualize this thing here. Well, whenever you have a power of whenever you have a negative power, visualize it as 1 over e to the power of 2 natural log of 2, and then this is the same as e natural log of 2, and then you squaring it. Okay, so this the point is that you can visualize this here as this thing here. Okay, so anyway, think about it, and then overall the overall answer should be roughly this. Okay.